Whew, okay, getting started. Welcome back. This is my fourth day doing this vlog, and I have noticed already talking in front of the camera is getting a little bit easier. I can let some of you let me know if that's different or if it's not. My main thing that I've been working on is trying to just stay really present in this. And it's such a different thing to think about talking in front of a camera and having some sort of emotion. And I think we do that very naturally when we're just talking, but when we're doing it in the sense of I'm talking to a camera, but I have to think about I'm talking to the people that are watching this. And so just being who I am very naturally. And that's led me to just taking a moment and then just kind of like making some, some faces, some things to just change your expression, and then have like a smile with the eyes, they say. That's what I'm trying to do. I don't know, maybe I'll come off crazy. Something like that. I know that yesterday I spoke a lot about accents and moving around, and I've definitely done that, and I've had a lot of sense of not really feeling like you fit anywhere. And I grew up in California, as I've said, and there's some great things about California. Even though I grew up in a small town, when I visited other smaller places in America, I was like, oh, no, we're not that small, but it still feels small. It wasn't like, say, LA or something, which is obviously massive. There's millions and millions of people that live there. But it is a different thing. But one of the things I never loved about California, and anybody that sees the news, say around this time, knows that it's so dry, it's so hot, and you get all these wildfires, and just the dryness just killed me. I never loved it. It's like yellow and dry and I don't know, death and desert. And some people love that. To some people, that's just great. They love the desert. And I imagine that would be really good for certain things. The sunsets were beautiful, sunrises, just stunning colors. However, I don't know, just didn't suit me. But yeah, living here, it's just green kind of all the time. So it's like cold tropics. It's humid, and it gets freezing constantly in the winter. But I don't know, I really do enjoy it. And if I move anywhere else after this, I don't know, somewhere Scandinavia, something like that, in a number of years. And one of the things that I was thinking about, because I was talking about randomness and probability, and I feel like I should just give the basics of what they call an axiom. So in mathematics, you have theorem, depending on what you're doing in math, it varies so much. But you can have the gods do not want me to talk about that. No, I'm just kidding. I'm going to leave that in. That's just an edit. It fell down. Anyways, there's a whole gamut of different types of math. If you could be really applied and you're constantly using mathematics to solve real world problems, that leads into engineering, that leads into trying to use really large scale computer programs to solve problems. And then on the other spectrum, you have pure mathematics. For example, number theory is a really good example, and you're dealing with the idea of what numbers are and certain properties of just the whole numbers, the numbers that you can count, 1, 2, 3, 4, all of that. And probability ranges across the board because it has these things called theorems and these things called definitions and corollaries and lemmas that all deal with different types of propositions, different types of statements of truth or false. And I just wanted to go over the axioms of probability as a way to kind of just solidify what we've been talking about. And I think the thing to first off start with is that an axiom is like an undefinable, or it's an undeniable truth. There's no proof of the axiom, but it's there, and it's almost accepted as, okay, this is true. And that leads into whole other different things. There's a guy named Kurt Gödel that I'll have to double check the exact pronunciation of that. But he said that there were certain aspects in mathematics that were true, but you couldn't prove it. Or things that you could prove that were not true. So anyways, an axiom is like, it's just going to be the bedrock. It's the basis. So with probability, you have three fundamental axioms that you can base all of probability, and then therefore statistics, which, you know, you've got two massive fields, and anybody needs to know statistics kind of as a rule of life, it seems. So there's three axioms that I want to talk about. So if you have a probability of an event that is going to be greater than 0, that's one axiom. And I'll go over this like sort of generally, we'll hand wavy, vague, and then dive into it a bit more. Secondly, the probability of the sample space equals 1. And finally, the probability of the union of the events is equivalent to the sum of the probability of the events. Now, what that means, firstly, is that probability is greater than 0. Which makes sense, because you're really talking about, like, here's a thing that I want to understand. What percentage, what proportion is it likely to happen? Is it something that's going to happen often, not at all, or so, like, infrequently? And that means that you're dealing with this idea that, okay, something is happening. It is something that will occur, possibly. That means having a negative probability doesn't really make sense, because, I mean, how do you specify a numerical value of what side the coin is going to be? Is it going to be heads or tails? What's the negative of that? I mean, you could make some sort of statement about defining what a negative probability is, but that would be kind of taking another step with the probability. So then that's like, okay, well, what's an event? And we've talked about this before, where we've said, okay, look, an event is like, you've got heads. The event that you flip a coin and you have heads. And if you talk to anybody in probability, you see that what they often do is use really simple examples. But often when you're looking at like really complicated problems that maybe you have to actually use a computer for, then what you have is like a sequence of really simple problems that are brought together for a really complicated problem. So you have an event. Now, an event, like we talked about, heads, tails, or the height of somebody or the weight of somebody, all of that can really be. I'm just trying to get the right light. Ooh, that's better. You see these lines, don't you? That's okay. All right. What are we doing? Yeah. Okay. As a little break, just to have a look at myself. So you have events. And they're the thing you're interested in. You know, what's the probability that you win the lottery? Well, you need to buy a ticket first to actually be in the running. So then let's think about then a series of events, or all the possible events of something you're interested in. Another classic example of probability is cards. You know, what's the probability you draw a king in a deck of cards? Well, how many kings do you have? You've got 4. And how many cards are there? There's 52. So the proportion of kings that you have available to you is 4 divided by 52, or 1 divided by 13. So your event space is the second take. I swear, I dropped the phone and it must have pressed stop. Anyways, I was talking for ages. Probability, it gets you. I think the thing to remember with probability is, if you want to just start looking at an intuitive sense of it, it comes down to knowledge. It comes down to what you know, what you can know, and where you're at with that. I think that thinking about situations in the sense of, what are all the possible outcomes? We talked about decks of cards. There's 52 cards. The number of ways you can draw one card is vastly different to the number of ways that you can draw two cards or 3 cards. And the different combinations that emerge from that vary. probabilities ultimately can be thought of as thinking about what are all of the possible combinations of something I'm interested in, and then what are the number of combinations of the very specific thing that I want to know. If I want to know, let's say I had a backyard that was grass, gravel, and trees, and let's say each one of them covered the yard in a different amount. Let's say 20% grass, 10% gravel, and 70% trees. Then what we have is a probability measure of 3 different elements. We've got grass, gravel, and trees. With grass, that's 20%, the gravel's 10%, the trees are 70%. I'm going to have, and let's assume that I have a ball, I throw it up in the air, and I'm going to assume that there's no overlap between the 3, and that it's going to land in one of them. That means that the probability that one of the events will be chosen as the winner is 1. And also that the probability of each of them will be proportional to the percentage of land that is covered. So the probability that I land in grass is going to be 0.2. The probability that I land in gravel will be 0.1. The probability that I land in the trees would be 0.7, because it's proportional to its relative percentage. So what that means is that the total amount of area, let's say that was 1, and each of those was some ratio of that. So if I had a fraction, and that fraction represented my probability, the bottom is the total, and the top is the specific. So 2 divided by 10, 1 divided by 10, 7 divided by 10. Play that out, that gives you your probability. So when you have a probability, it's always greater than 0, and it's always less than or equal to 1 that your specific event that you're interested in will occur. Also, that the probability of the union, so a union means, what's the probability that I land in grass or I land in the trees, or maybe I land right on the intersection of the two, and also the gravel. Those are unions. So then the probability of the union of all 3 of those, basically it's saying any one of those will be equal to the sum of all of them. So then if I sum up every single event, the probability of every single event, so in this case, the third take. Wow, this is hilarious. So much for that one take, no edit bullcrap. I've been going on about probability for ages. You know what? Something that I just love is I took a course in probability when I was doing mathematics. I took a number one, but my first one was taught at the University of Queensland by this professor, Phil Paulett, and he's pretty stern. I remember one time I have this, if anybody knows me outside of this world of tube, I can mix between being relatively anxious and relatively blasé about everything. And I remember I walked into his class late first day because I needed to get a coffee, because why not? And most teachers at university are like, yeah, whatever. I don't care about you. You don't care about me. Let's just sit down. But he made a point to stop and let me find my seat. A little bit too assertive, I would say bordering on aggressive. And so you had elements with this guy where you're like, is this guy a jerk or what? And yes, he was. But at the same time, he was incredibly fair. And the dude just knew probability. The way that he thought about things, I thought was awesome. And it was sort of like, you take calculus, like, oh, well, if we want to find the optimal size of a can with it's got a radius r and a height h, and what is the amount of surface area that is minimal so that the volume is maximal. And it's sort of a classic calculus problem, but it's really contrived. It's like a can, really, okay? And if you're doing this for work as an engineer, I would imagine it would be much more complicated than that, and all these other things that you had to consider and all this stuff. So I never really felt like that was a true application. But then in probability, you're thinking about a likelihood and something happening, and different events have different shapes that show how likely something's to happen. And so, you know, it was just somebody that knew it on a technical level and at an intuitive level. So it was really fantastic, and it was such a learning experience in terms of probability. But he was also incredibly fair because, you know, the class was really hard, and at the time I was just doing my first year of calculus, but that was the second year probability course. I just thought, what the hell? I did that in real analysis in my first semester at university. I didn't ace them, but I did pass them. Oddly, I didn't pass the first year calculus because I think I was so focused on like the actual harder real math as opposed to kind of the basic stuff. But then the fundamentals kind of kick you in the butt if you don't have them. So, you know, lessons. Anyways, finals comes up and he says, all right, here's question 1. It's going to be about this. Question 2 is going to be about this. And he gave you all 8 questions of what it was going to be about. It didn't matter because he knew how to give you simple questions that turned out to be hard AF. And that's what I loved. It was like seeing something so simple and yet being able to ask a question that was so deep. So yeah, I think that's one of the things that helped me just sort of start really being into probability. And I do a lot. All right, last video. Look, I'm going to stop there. My phone needs to be cleared of memory. Thank you so much for listening. I'm going to put these up, stitch them together. And look, if you like this, hit like, hit the bell for notifications to hear my ramblings, and subscribe. Thank you so much. Have a great day. Bye.